All right, guys, let's take a look at this expression. We have x minus 7/12 equals 5/10. Our goal today is to try to find the value of x. One of the ways to do that is to isolate that variable, okay? And right now I have x and negative 7/12. So one way I can get rid of that negative 7/12 is by putting in a positive 7/12 to have that zero pair. If I add 7/12 to this side to maintain balance, because we know that equal sign means both sides are balanced, I would have to add 7/12 to this side. Okay, then I simplified this expression with my zero pair, and I'm left with my x, isolating that x, which was our goal. On this side, I've now created the expression 5/10 plus 7/12. Okay, and we're going to think about taking our rational number in decimal form and turning it into fraction. So I'm going to say that x is, let's see, if I have a half of 12 is 6. So I have 6/12 plus 7/12. So turning my 5/10 into 6/12. Okay. So one way of simplifying this expression is to kind of think about how I can decompose one of my addends to get the other one to a friendlier number. Okay. So I know that this is a half. Can I pull a half out of my 7/12? Well, if I decompose it, I do have a 6/12 hiding inside there. 6/12 plus 1/12. So then I can find that friendly number. So this 6/12 plus the 6/12 inside my 7/12 will make that one whole. So then I have another equivalent equation. That 1 plus 1/12 is the same thing as I have here, I have here, I have here. So that helps us simplify that expression where it makes the equation x equals 1 and 1/12. Okay, let's look at another example. Here I have an equation, x minus 5 and 5/21 is equal to 3 and 6/7. Same thing, our goal is to solve this equation by isolating the variables so we can find its value, okay? So if we want to, on this expression, get rid of my negative 5 and 5/21, thinking about our zero pairs, I'm going to put in a positive 5 and 5/21. To keep that balance, I have to do it to the other side. Okay. Then when I go to simplify my left-hand side expression, that zeroes out. I've isolated my variable. My expression over here is now 3 and 6/7. And I'm adding those positive 5 and 21/100. Okay. Again, thinking about how we can decompose to get to a friendly number, I know that I can rewrite 6/7 as 18/21 just to help us see it. So I'm going to rewrite that expression. Okay, so then here, my 3 and 18/21 is definitely the closest to 4. So I am how far away from a whole? Let's see, 3/21. Can I pull 3/21 out of here? Yes, I can. So if I decompose my 5/21 into 3/21 plus 2/21, okay? So we're going to think about this expression with that decomposing. All right, so that means I can pull my 3/21 and add it over here. That takes me to my 4. Oh, I can keep it that way. And then I can recompose very easily, which is what our goal is. So then I know that my sum here is going to be 9 and 2/21, which means this was equal to x, this was equal to x, this was equal to x, and then that simplest form, we make our equation that x is equal to 9 and 2/21. Okay? All right, one more example, but we're going to look at an equation that has rational numbers in decimal form, because this same understanding applies. Again, we're thinking about isolating the variable to help us find its value. I have a negative 16 and 8/10 connected to it. We know that it's equal or balanced to 4 and 2/10, so we want to get rid of that negative 16 and 8/10. If it's negative, zero pairs. We're going to put in a positive to keep it balanced. We do it to the other side. Then we simplify our expressions on each side. This zeroes out. And I'm left with x is going to be 4 and 2/10 plus my 16 and 8/10. Okay, trying to get one of my add-ins to a whole value so we can use our place value understanding. I'm gonna go this direction, let's see, because this is only 2/10 away from 17. I can decompose here, my 4 plus 2/10 plus my 16 and 8/10, and then recompose. I'm gonna recompose these together, which means my new expression is 4 plus 17. So again, this is equal to x, this is equal to x, and then very quickly I can get to x has a value of 21.